Hello everyone, I'm Ahsan Zaman. I'm a marketing director at Silana Semiconductor for FirePower laser driver family of products.
I'm Brian Cabico. I'm the application engineer for FirePower products of Silana.
Today we are in the lab going over a complete test setup for one of our evaluation board. So what we have here is an evaluation board that we have specifically developed for Rangefinder applications. And in this lab setup, we're gonna go through our graphical user interface that allows us to configure various features and performance adjustment through the intuitive GUI into the hardware and show you a live demonstration of changing various parameters such as pulse width, peak power that is going to be useful for rangefinder applications. And in this setup, we have our evaluation board connected to an photon detector as well as an integrating sphere to get all the measurements that Brian will now introduce through the various equipment in our lab settings. So with that, let me introduce you to Brian Cabico, our application engineering expert.
Let's go. First, you need safety, so we're wearing safety glasses. The SMU or the power supply will be the one in charge for the input to the board. So we're setting up at 5 volts, and then we set the limit to 1 amp. Then we have the waveform generator. The waveform generator, it will be the one to put the clock signal. So for the setting, we set it at 1 kilohertz frequency, which is usually the frequency for rangefinders. Then we set the amplitude to 5 volts. And then we have the integrating sphere. This integrating sphere captures the power of the light. So this is connected to the power meter. And then we have the photon detector. This photon detector detects the light and captures the waveform that will be shown in the oscilloscope. So you will be able to measure the FWHM, or what we call the full wave half magnitude. And from those values, once we get the FWHM as well as the average power, we'll be able to compute the peak power using our GUI.
Okay, so we are now going to show you a live demo of our evaluation board. So in order to do that, first we are going to start with our graphical user interface, the GUI application that we have developed to interface with our IC and change various parameters through the I2C interface. So in this GUI, the first page is setup, and here you can see the component is SL2002, that is our FirePower laser driver product. And once we start up, we can directly go to the timing calibration tab, which will be the main focus of this video. And we're gonna show you how changing various timing code here, for example, the flux time, charge time, and fire time code, we can make changes to the hardware and show you various pulse width and peak power operation. So first, to introduce to this interface here, it allows you to select your operating conditions such as input voltage, the component you have on board such as fluxing inductor, the series capacitor value. And in addition to that, it gives you an estimate of what to expect from your setup. What to expect in terms of peak current, what to expect in terms of VCAP voltage, as well as various timing after you change their hex code in this GUI. Once that is done, you can just click on Write to I2C button, and it allows you to program the IC with this timing code. And here you can see, if you look into our power meter, which is connected to our integrating sphere that shows average power. Right now it's showing 3 milliwatt. And in addition to that, it is also going to show you with our photon detector how the pulse shape looks like. So if I move my integrating sphere here, now I am exposing the laser output directly to the photon detector. And the photon detector here is capturing how that peak waveform and then the full wave half magnitude gonna look like. So once you have that waveform, this GUI actually can take that data and help you calculate the peak power, the energy through a tab called Peak Power Calculation. So in this Peak Power Calculation tab, first you have to give it some input from your measurement setup. So for example, we saw our input average power was about 3 milliwatt, and V in is our input voltage that is shown here as 5 volt. And then the input current is shown as 0.988, so about 1 milliamp. So once we have captured the CSV file from the oscilloscope, we can load that file into the GUI using this Load CSV button. And you have to identify what you have captured. For example, here we have captured both our VCAP voltage as well as the light pulse output. So we are going to show that column A is our x-axis and our light pulse output was column C in the CSV file. Once it is captured, you can clearly see here that the graph we are getting in our graphical user interface GUI matches exactly same as our oscilloscope waveform. So that kind of gives you a good confidence that the CSV file was able to capture the data accurately and the GUI is able to measure and retake this data, come up with the peak power. Right now here is showing the peak power of about 58 watt and also the full wave half max value of 48 nanosecond. So with that, you can see the complete picture that the GUI not only allows you to configure the IC, but it also takes the real data from the oscilloscope and able to give you the peak power and the full wave half magnitude values calculated directly from there. In addition to that, before we're gonna play with the GUI, just want to show you that we also have a simulation tab in our GUI that allows us to simulate prior to running the experiment. So for example, once you have your timing calibration set up with various register values, with those values, you can go to the simulation tab, and there, all of that values are already preloaded based on the timing calibration input, and it allows you to run simulation. So once you press this button, load values to the schematic and run simulation, this is a simplified schematic of the product we have, SL2001 or SL2002, combined with various external components that allows you to simulate and show you a graph of various waveforms before moving on to the experimental setup.
The GUI allows us to see the programmability and configurability of SL2002. So now I would like to show you how we do that. First, we have the timing calibration screen of the GUI. So we want to program the flux code and the flux time code and the fire time code. So if we want to adjust the pulse width of the light, we can adjust the fire time code here. Like right now, it's set as 0x f8, which converts to 189.5 nanoseconds estimate. So we can adjust it to shorter, like for example, let's say we set it to CA, which converts to about 50 nanoseconds. So just write it there, write to I to Z. And you will see a change in the waveform there. Now, you can see how the light pulse changes. And then if we want to change the value of the VCAP, for example, we want to change it to like 18 volts or something. Let's see, increase the flux code time from E5 now, which converts to around 452 nanoseconds flux time. We change it to, say, E9. Now it's 500 nanoseconds, right? You see how the VCAP increases. Also, once you write to I2C, this will be reflected to this simulation tab as well. So you see the 499 nanoseconds there and the 49 nanoseconds flux time.